This is a long class today. Okay, so today we are going to go through chapters 1 through 5. There are 13 questions out of the 50 that come out of these 5 chapters. So we're going to concentrate on things that you need to know out of those 5 chapters. Then next time we'll do chapters 6 through 10. And then May 16th we'll go back over the organic, which is the 11 through 13. Okay, on the 16th I'll give you your review that you can go over on your own. I will put up the answers to it over the weekend. And then on the 20th, we'll go over the review. So make sure we understand it. And then 22nd, we have a test.
We have so many more days of review. It's kind of awesome.
Well, this test is worth 20% of your grade. So I want to make sure you understand it, you know it, you can do well on it. Okay? You're welcome. Okay, so here we go. Okay, so 1 through 5. If it were me, I'd make sure that I wrote down everything that was going to be on there. There's 13 questions. Some of them I've combined onto one slide. You'll understand why. 13 out of the 50 come from these 5 chapters. Okay, so here we go. First chapter, review. Matter and measurement. Remember, matter can be split into 2 different groups. Pure substances and mixtures. Substances break down into elements and compounds, mixtures, heterogeneous, homogeneous. Okay? That's about it there. Okay, you need to be able to take a number and move it from scientific notation to decimal form or decimal to scientific notation. I have up here just decimal going to scientific, but make sure you know how to go back and forth. I figured if we knew how to do one way, we could do the other way. So looking at the first one. What should your answer be? Write it down. Let's see if you get it right. Do 1, 2, 3, and 4, but I'll explain stuff in between. I've given you sort of the definition on the left, so if you've forgotten what it is, because this is from the very beginning of the year, but we have been using it, so hopefully it'll be fresh stuff. Yep, you've got to put in a scientific notation, all of them. There's a scientific notation for all of them. And I forgot to fix number 2. So we'll fix it when it comes up. I was making this really fast last night as I was looking at the test, and there's some typos. So just deal with me. Live with it. Okay, so on number 1, let's go through number 1 real quick. You have a decimal right here. You need to move the decimal 1, 2, 3, 4, 5, 6, 7, 8 to get 1 in front of it. So you are going to put this as the answer. Okay? You have to use all the numbers that are there that are non-zero. If the zero is between 2 numbers, we count it. Okay, on the next one, it looks like I heard some, well, how do I put this in? Yep. Right, so in order to put it in, oh, no. Yeah, this is an 8. This is my boo-boo. 8.9. That's what happens when you copy and paste.
I was like, I said 8.9. You said 8.9. I said 1.2.
Okay. All right. Has everybody got number 3? On your own. Did you remember to put the 0 at the end? If you didn't, it's wrong. Okay, that 0 tells me how well I measured right here, so it needs to be included in the scientific notation. Okay, that's an important thing to remember. Hint. Number 4. We got the answer to the number 4? Okay, let's see how we did. Okay, how do we feel about this so far? Good? Okay, just remember a 0, if it tells me how well I measured, it has to be included in the scientific notation. If it tells me how big or how small, it's not included. It's part of the times 10 to the whatever. Okay? Second part, anybody remember anything about this? And what does the heart mean?
Volume is density.
Mass divided by volume is density, yep. So we're going to use it in an equation. So an example would be like this. She can give you things that are not in the unit she wants it reported in. Make sure you're careful and get it into the unit either before you put it into the density equation or convert it after you get in the density equation. So there's some stuff down the center. But everything else put away. Okay.
General formula, grams per liter.
She will usually tell you at the end what to express them in. Be careful to watch for that. Okay. So we've got liters. You either need to convert it before you put it in or convert it once it's in. It depends. I mean, you could take this and now go like this, and 1 liter is equal to 1,000 milliliters, get the answer and plug it in. Or you could take density equals mass divided by volume, 64.52 grams divided by 10.84 liters. Factor label it, and get your answer. So there's 2 ways you could do it. Yes, sir?
You don't happen, ladies using your laptops. I wonder if I can borrow one.
Oh, yeah, you can borrow one. It's like ladies using your... We're using them later, but...
Later out.
Yeah. And we've been using them, so I told them they couldn't take them. So, but my classes are small enough, one's not going to hurt. Okay. Yes. They're on my... Okay, what do we got for an answer? Try it again. Give me it to me again. 5.-3. Okay, now it will be reported in scientific notation if it's bigger than 1,000 or less than 1,000th. Okay, so make sure you're careful there. So if it's bigger than 1,000 or less than 1,000th, it needs to be in significant or scientific notation. Please be careful converting. I almost would suggest doing it this way first and then plugging in, because a lot of kids get it mixed up where the 1,000 goes. Because on the top one there, it goes on the top, but on the bottom, where we put it in, it goes on the bottom, so they get confused, yes.
You need to know weird units like deciliters.
No, she sticks pretty much to the main ones, milliliters, microliters. No, the kiloliter, 10 to the 6th. Yeah, but 10 to 6 of one. Okay, going forward. Chapter 2. So now we're in Chapter 2. Chapter 2 is all about isotopes. We've been using isotopes, so that hopefully this will be a review. It's about the periodic table and looking at the periodic table. So if we have 12 isotopes of carbon, they're all listed right there. And the average mass of carbon is 12.011. Which isotope is the most abundant? You guys are a lot faster than 5th period. Done.
Is there something like that on the test?
Yes, there is. Okay. All right, next one. This one is a little bit more confusing on the test, so I wanted to show you one like it. She will give you something like this and say which one is correct or which one is not correct. So you have to go through each of them. Look at the first one. Is this set up correctly? What's wrong with it? Right, these two need to be switched. Good. You guys catch this really fast. I'm impressed. Okay, what about B? Correct or not? Why?
22 is TI.
Okay. 22 is TI. Okay. All right. So what about numbers or letter C? That one is good. Okay, good. What about D? What's wrong? It's backwards. Okay, so just remember the top number is usually about 2 times the bottom number, and that will help you. Remember, the top number is the mass number, bottom number is the atomic number.
And the top number is the
Neutrons plus protons. And the bottom number is the number of protons. Okay, we okay? All right. Next is ionic compounds, bond, James Bond, give and take. Okay, just remember, ionic bonds is all about I, me, because I'm giving or taking electrons. Okay, that's my favorite bond anyway. All right, coming forward. I've got several questions rolled into this one. Okay, so first of all, we need to be able to see what ion an element would form. So magnesium will form what ion? Plus 2, 2 plus. Yep. Phosphate, what is it? So there's some polyatomics that you're going to need to know. Phosphate, carbonate, sulfate, acetate, hydroxide, the generic ones, the ones that we've been using all year. Okay? We need to then be able to take these two ions and put them together in a compound correctly. What's the compound going to be? Okay, common factor was 6, right? So in order to get 6, I need 3 magnesiums, I need 2 phosphates. Okay, now I need the name of the compound that I made. This one's easy, right? We just smash it together. Okay, just phosphate. Okay, aluminum. What's the symbol? Charge? Plus 3. It's part of the slide, we do know. Okay, sulfur. Okay, formula. Name. Good, I'm glad to hear I heard sulfide. So you need to remember that this ending is IDE. Okay, she might just put on there aluminum sulfur as one of the answers. I hope it sounds wrong. Good. Okay, do the last 2 real quick on your own. I'm going to have people come up and do this. Caleb will have you do the rubidium and sulfur. Jacob, do the bottom one. I'm planning on putting all of the reviews from all 3 periods up on Canvas for you.
Arsenide sounds wrong.
It's right, though. Yep. It does sound wrong, but it is right. Yeah, it's a mixture. Krypton and other things. Mm-hmm. Hello. Just this period, yep, as long as you bring it back. Don't forget to give me a formula. 1 through 5. Three, I think.
That says ours.
That says arsenide. Okay. Yeah, it struggles at the bottom of the board. Okay, how do we do? Other than this arsenide should have a, the E on the end. We doing okay? You did it right. If you got it right up here. So good job. Okay, let's move forward. You need to be able to look at a formula and tell me if it's written correctly or not correctly. Okay? I'm going to review really quick while I'm over here at the periodic table. Remember that you can get the charge of a polyatomic that has oxygen by knocking out oxygen and fluorine, moving that top row over. 1 away is -1, 2 away -2, 3 away -3. Okay, so but oxygen and fluorine got to knock out and move over, and that's when we're adding oxygen. So what else? Okay, that helps us here. This one right here you've got to recognize as acetate, CH3COO. That's how we write it organically. Okay, so first of all, what's sodium's charge? +1. What's acetate's charge? Does anybody know? It's -1. Is this formula written correctly?
No.
What is the correct way to write this formula? Okay, good. Okay, next. Inorganically, we write it C2H3O2 when we're writing it inorganically, yes. Put them back in where the chemical store is. There's a cart right outside. Just put them there. Okay, next one. Okay, double checking. This is a +2. That's a -3, right? Common factor 6. We're good. Okay, next one. Ba is what charge? 2+. Hydrogen is? +1. CO3 is? Does that equal 0? So it's not written correctly. So how do I write it correctly? That's a group. So whenever the hydrogen's in the middle of a compound, it's with whatever polyatomic it is. Yes?
So how come it's a group but they each have separate charges?
I did it separate charges because you already know what hydrogen is, right? And you knew what CO3 was. So you can figure out what the charge of the whole polyatomic is.
The whole thing is like
So this whole polyatomic right here is -1. Yeah. But I'm showing you how you can figure it out if you don't know. Okay, what about this one? Correct or not? Why? What's good? It's not right. What's potassium's charge? +1. Okay, what's sulfite's charge? -2. So what is the correct formula? K2SO3, correct. Okay, next one. Right or incorrect? Okay, what's strontium's charge? +2. What's nitrate's charge? -1. So, right. Okay, last one. So copper's in the center, right? We don't have a rule for it, but what normally are the charges from what we've done this year? Does anybody remember? It's either a +1 or a +2. It's more common +2. What's phosphate's charge? Look, where's that? How far away is phosphorus from being a noble gas? -3. So we have 3 times -3, which is -9. That can't be right. So what are 2 possible ones that would be right? Cu3, PO4, and another one? In parentheses 2. Okay. So you can see how you can figure them out. You've got to be able to tell me if it's right or wrong. Okay? All right. Now, this one, how many remember this?
Yeah. I remember
Okay, what's the most electronegative on the whole periodic table?
fluorine.
Fluorine. What's the least? Francium. Okay, so first thing I would do if it were me and I have one of these is I don't just quickly figure out where they're at. I put their numbers down. So let's go do that. Molybdenum, what number? It's in the D. 42. Cadmium, what number? D. Indium, what number? Rutherfordium, 104. Tellurium. Arsenic. And cesium. Okay, out of those that we found, which one is closest to francium? Francium. Cesium. Okay, so it wants us to go from lowest to highest. So lowest here is cesium, right? Which one was close? I can knock that out. Which one was closest to fluorine? Arsenic. So I'm going to put the two ends there. Okay? Were there some on the same row? Okay, which ones were on the same row? These, right? They're going to come straight down as is. Right? So that leaves one right here that I need to find out where it goes. Which one was it close to? Cesium or arsenic? It was closer to cesium, right? Because 104 is over there. Okay, so I'm going to put rutherfordium here, and the rest I just go CD, indium, and TE, and I'm done. Oh, MO. I should have put MO in there right here. Mo, right there. Okay? But that's how I do it. If you've got an easier way, great. But there's going to be several answers that are really close to each other. So if it were me, I would take them, I would write them down on my scratch paper, I would find them, I would rearrange them down here, and then I'd look for my answer.
Where is hydrogen?
Hydrogen is off in its own little world. It is less electronegative. It's considered more over there than over here for electronegativity. Okay? All right. Chapter 4, covalent bonds. Chapter 4 on covalent bonds. Just remember they're sharing or slightly polar. Remember on water, we do get the polarity in the molecule. But they are sharing bonds. They don't have enough strength to rip off the electron from the other person or the other element. We need to be able to name them. This is pretty easy, right? What's the first one? And okay, quickly write the rest of them. Okay, should be really fast. I'm not going to have somebody come up and do this right now, but we'll do other things later. If there's one that you did not get, please let me know. Why? Everybody do okay on this? Just remember your prefixes. Pretty easy. These need to be, if you're looking at the P right here, here's your D. These are the staircase, remember, and up. That's the only time you can use monoditri. Staircase and up, and they've got to have two and only two elements. So a couple of rules there. All right, so this is the one that tripped up a lot of them, but is very easy. You got to think back. She's testing you on Lewis dot. How many remember how to do Lewis dot? Okay, how do you do it? Can you explain it to us?
I don't know how to explain it, but I can only do it.
Okay, just remember D and F don't count. So if something's in the D and the F, you have two valence electrons, and that's from the S. You go look only on the row that it's on, and you only count what's in the S and what's in the P on that row, and that row only. Okay? So if I look at nitrogen, how many valence electrons does nitrogen have? 5. 1, 2, 3, 4, 5. We know how to do that. How about oxygen? 1, 2, 3, 4, 5, 6. Now, the nice thing about counting valence electrons, I don't necessarily have to draw the lowest dot. I just have to remember how much there were. So nitrogen had 5. I have 1 of them. Oxygen had 2, and I had 2 of them. There were 6 on each of them. If there's a charge, if it's negative, I add it. How many total valence electrons do I have? 18. Done. Would you do the other 3? If it's a positive, I take it away. So it's opposite. You got to remember opposite. A positive, you take an electron away. So you add your normal valence electrons, but you take one of them away because you're one short. Your protons are in the center, right? So if I have negative, that means I've added electrons, but if I have positive, I've taken an electron away. So do all of them. Well, I'm going to have you guys come up and show your work. And let's see. Jace, let's have you do MnO4. Aspen, will you do NH4? And Carly, will you do PO3 3 minus? If you need help, let me know. I'll come around and help you.
Did you say my name?
No, I did not.
You got two physics.
Not that I ever need help.
As soon as you get them done, go put them up. One more time.
N has 5.
Right. You're doing this one.
H.
H has 1, and then it has a positive, so you have to take 1 away from your total
So
because
then,
it lost 1.
why did you do 2 and then 6 in parentheses plus 1?
So, grab a pencil. So, NH4 has a positive charge. So there's 5 around this one, and there's only 1 of them. There's 4 that have 1 around them, and then this says I am going to lose 1.
Okay.
Okay, so how many are we going to get overall?
9 minus 1, 8.
There you go.
Oh, you're right. We were both right on that top right one, because it gives us the M and gets Oh, nice job. Are you gonna see?
Wow, we went to chapter 5. Oh, there we go.
We're back. That corner is really a pain. So, okay, let's double check all these for everybody. I'm not sure what this is right here.
6 times 2.
Oh, okay, 5 plus 6 times 2 plus 3 equals 20. Got it. I was like, remember we don't use X's now, you know, because they're not, yeah. Okay, so this one is, I'm guessing that's a 4, right? 2 plus 6 times 4 plus 1 is 27. And the bottom one, 5, which is nitrogen, plus 4, which is hydrogen, times 1, minus the 1, that's from here, is 8.
I like it. And B times
It should be a 3, yep. So 6 times 3 is 18, plus 5, plus 3, 26. Okay. Any others? We okay? All right, going forward. Chapter 5. This is all about chemical reactions. So, just a quick review. Top one. Top one is what type?
cis combination.
Combination, or another word for it is synthesis. Okay, decomposition's next. Okay, next one. Single displacement. That's right. Or a boyfriend. Okay, next one. Or dance disaster, right. Okay, there's one more that's not listed on here. Does anybody remember what it is? It is combustion. So really quick, going back over them. Double displacement, dance disaster, right? Single displacement, stilling, right? Combustion, kaboom. You end up with oxygen going to CO2 and water, or incomplete, you get CO and water, right?
Then you have weird fractions.
Yep, then you have weird fractions. Decomposition, you fall apart. It can be one or lots. Okay, so you start with one thing, you fall apart. Okay? Synthesis, you start with two things making one, and the two things can be compounds or elements. Okay? All right, so let's go forward, see what we can do here. Again, we're going to do several things at once. So, tell me what type the top is. Okay, now we're going to balance it. How many remember how to balance? I'm going to do NO3 together because it sticks together on both sides. Okay, so PB, 1, 1. Chlorine, 2, 1, 2. AG, 1, 2, 2. 2 NO3s, 2 NO3s, done. Okay, you get a label and balance the rest.
Are we gonna have it with like 3 people come up?
Yep.
I volunteer.
Nope. You already are up.
I don't want to do it on my paper, so I can do it.
Nope. Okay, so Tiani, you got 2. Justin, you got 3. Hello. If they're not balanced, you need to balance them. If they're already balanced, you're good. I was tricky on the last one. All 3 were balanced. I was giving you a hard time. Okay, so combination, single displacement, we're good. Okay, now the rest of you get to do these. Okay, so Jade and Dean, you get number 1. Tyson, you get number 2. Caleb Smolin, you get number 3. And Caleb Brown, you get number 4.
Let's go. I haven't even done it yet. Do it. It doesn't matter what order we do it in.
But you got to get down so the ones behind you can see what they're doing. When you go to do these ones, and they pull them off, make sure you take these off and then put them like back to back so it won't mess this part up. And then put them in here. Okay, we got them? Let's get them up there. Taking everything. She doesn't want it. Yeah.
Who's coming in here?
Roberts is moving here. And then in Roberts' room is the new astronomy teacher, which we don't know who it is yet. But we're trying to convince Banks to move down to there because that's a straight entrance into the physics room. And then Holtree would move down one. But it's sort of like a domino effect. So. But he wants this thing in there for this physics. And I don't think it's in. They hang things on it to do motion stuff on it. Sorry.
I don't know. It just depends. My dentist was trying to have me get my wisdom teeth out before or on the day of the test. I said, no.
Good choice.
Weird.
Is that hard?
Oh, wait. This is why, wait. I put C6H.
Now we have 3 perfect.
Oh, wait, I got it right. Did I do this right? Because I know that because when we were doing it, it was really weird.
Yep.
60.
You're good. Tell me what type it is, too.
I was like, why is this? I just put D.
Sure.
It's the double D. The Dirty Diana.
We got some Michael Jackson.
Yep. It's a good song.
Okay.
Is there the Weeknd's version of Dirty Diana?
All right, let's click this through. Were you able to do this? This is the first thing. Did you have any struggles with this? You should be able to balance. You should be able to tell me what type. Okay? Yeah, if you make sure you copy it down right from the screen to your scratch paper when you're doing the test. That's important. Okay? I really messed him up. That was supposed to be a 4. Nothing?
Nothing. You just did a good job.
All right, so going down, combustion, yes. Decomposition, yes. Single displacement, yes. Double displacement, yes. And I believe they're all done correctly. So good job. Balancing. Okay, next one. This one takes a little bit of thought. Here she is testing the mole map in your brain, but she doesn't want you to do calculations. Yeah, so this is how you do it simply. First of all, I want you to quickly add up, and I don't mean using the whole thing. You're just going to look and say, oh, this is about 23, and I'm going to times it by 2, and this is about 16, and I'm going to add those up. Okay? Really quick, get me the formula masses, fast as you can. Just really quick, dirty. This one's 62, okay? What about this one? What about this one? What about that one? Get them real quick for me. Yeah, you just you round it. Round each of them. Just to a whole number. So like this one would be 12 times 5 plus 10 times 1 plus 4 times 16. 98 here? No. 3 times 1 plus 32 plus 4 times 16. You got 98. Okay. This one right here, 2 times 39 plus 32 plus 4 times 16. What'd you get? The third one you got what? 134. Okay.
190 something on the bottom right. Just round this.
That won't be 190. Bottom right.
You got to do math. 90,
80 plus 70, 150-ish. Right?
174 is
Is it 174? Is that what you guys got?
around 190.
Okay. So this is what you do with this question when it comes up. You look at it and she says 25 grams of each, or 50 grams of each, or 40 grams, or 30 grams of each. Remember that 1 mole of a substance is what we add up the mass to be, right? How many molecules are in 1 mole? Avogadro's number, right? Count me up on Avogadro's number. So this is equal to 1 mole, which is equal to 6.022 times 10 to the 23rd. If I have that much of it, okay, I've got about half of that, right? About. Half of this many molecules. Because that's about half-ish. Okay, so I have about half that many molecules. Well, if I take these, it's a lot less of that, right? Got a lot less, got a lot less. So this one has more molecules because it's got a lower mass. Okay, so the one with the lower mass has the more molecules. So which one has the least? The one that weighs the most. So this one contains the smallest number. And this one contains the most. Okay, but it makes it very fast and easy. She's not going to have you do the calculations from the mole map. It's just, you've got to do that kind. Because it only takes 62 grams of this substance to get 6.02 times 10 to the 23rd. Where it takes 174 grams of this compound to get 6.02 times 10 to the 23rd. It's like if I have 25 pounds of elephant versus 25 pounds of mice, I'm going to have a lot more mice than I am going to have elephant. I'm going to have just probably a knee or a trunk. Okay? So that's what you got to think of it. You got it? Okay. All right, here we go. Next one. We are now into redox within part of the chemical reaction. So, first thing you need to remember is any element by itself has what charge? 0. So anytime there's an element by itself, I come and I put a 0. Now, I need to figure out the other charges. We need to remember first column plus 1, second column plus 2, third column plus 3 till you get to gallium, then it slides to plus 2 at zinc, and silver's plus 1. Fluorine's always a minus 1. Oxygen's a minus 2, except when it's a peroxide where it can be a minus 1. When it's by itself, no. But when it's in a compound, yes. So here we know oxygen's a minus 2. That means mercury had to be a plus 2, right? So then we're going to connect side to side. Mercury's changing and oxygen's changing. How do I remember which one's which? There were 2 things that we could use.
Reduction is gaining, so the
GR. So Leo, the lion, says GR. Leo, loss of electrons is oxidation. GR, gain of electrons is reduction. Or oil rig. Oxidation is loss, reduction is gain. But you got to remember it's the electrons with that one. That's why I don't like that one as well. Okay? So if I'm gaining electrons are negative, and so I'm going to become more negative. So I remember grrr. That's sort of a negative thing. If I hear something growling at me in the outside when I'm camping, that's not a good thing. Okay, so it's negative. I'm going to become more negative. Which one of these two became more negative? The HG. So this one is reduced. The other one is becoming more positive, and it's oxidation. So I think of OxyClean. I'm happy when I'm clean, positive when I'm clean, so this is oxidation. Okay, next two, go. Oxidation is losing electrons. The electrons are negative, so I'm losing the dirt. I'm becoming clean. Okay? All right, let's see who's coming up to do these. Let's see. Yes, sir.
So what are the charges on the slide?
Boron, aluminum, gallium +3, zinc +2, silver +1.
And then what about indium with that?
They like to be +3, but they can be all different kinds of things. Okay, let's see. Let's do Justin, number 2. And Smullen, number 3. If you need help, let me know.
Yeah, Leo GR is a lot easier than oil rig. Oil rig is flipped.
Well, it's not flipped. It just doesn't tell you what you're losing.
Yeah.
And I'd like to remember it's electrons. Oh, yeah, electrons are negative, and then I can think it through. So if I Leo, the lion, says GR, I go GR first. Gain of electrons is reduction. GR, it's negative. And then oxy, I just remember you have to have reduction and oxidation. Oxidation is positive because it's lost the negative. It's the mother thing in me. Okay, so what?
CH4 neutrals?
Mm-mm. Let's just guess.
Oh, God.
C is.
Yeah.
Yeah.
There's no points will be given to this problem if the answer is found by process of elimination.
Why doesn't matter how I get the answer? It's just better that I got the answer, right?
Yeah, why do they care what the word is?
Where was that at?
On math.
Okay, you got the last one? Almost. Give him a few more minutes here. Oxygen's always -2 when it's in a compound. That'll help you find the others. Hydrogen's always +1 in a compound. For the most part. There are exceptions when it's becomes a hydride, when it's with compounds in column 1, 2, or the slide.
But that's not showing.
Here, let me help you guys. This is painful. Okay, hydrogen's a +1. You have 4 of them. Carbon is a -4. Oxygen's always a -2 in a compound. You have 2 of them. That's -4. You need a +4 to balance it out. Oxygen's -2. Hydrogen's +1. What's changing side to side? The oxygen is here to here, but they both go to the -2. Is it being oxidized or reduced? Reduced. Okay, what else is changing?
Don't you usually label what's positive first?
Doesn't matter. Carbon's changing, right? What's happening to it? becoming oxidized. As long as I get both of them labeled, it doesn't matter which one I label first. So it's the carbon that's oxidized, it's the oxygen that's reduced. It's not the CH4 that's oxidized.
And we don't know anything about
Okay, it's just the element. Yep. Okay, hydrogen stayed the same. Okay, going forward, I like this. How do catalysts work? I sang matchmaker, matchmaker, make me a match, and then this is how I turned out.
He is a match.
He is a match. Okay, so first up, do you remember this? What is it?
It's the activation.
Activation curve. So I'm asking, how does a catalyst work? Why would I put up an activation curve? It does. It lowers the activation energy, and that's what you need to remember. That is what it does. Lowers the activation energy. Okay, going forward. Next time, chapters 6 through 10. The rest of the time in the class is for you to do whatever you would like to do. Work on Alex, work on your labs, work on everything that you want to do. Okay? Make sure that your labs, your homework, your Learn Smarts are done and in by the 14th. Make sure that you have an 80% in labs. If you do not have an 80% in labs, I have to give you an F. So please have an 80% in labs. Redo, redo, redo. Get it in. Okay? Time is yours.